Good morning, Holy Cross students. Happy snow day to you. Can you believe it? We have another one. It's Miss Hall coming to you from my living room. We're going to try something a little bit different. We really haven't had a chance to do this, but I think you guys are going to be able to handle it. So I'm going to instruct just like we normally do in the classroom setting. The only difference is you're not going to be able to see my face and I can't see your beautiful faces. But I think you guys are going to be able to handle this, so let's get started. The first thing that you should have done is the IXL link, which you can find in my notebook under the Enrichment Activities tab. It was the properties of the parallelogram. Just remember to, if you haven't done this already, we need to go through, we need to do our 20 problems, and remember to take a screenshot of those and then place them in your notebook under our warm-ups tab. Okay, so if you will recall, we started our unit on quadrilaterals. And then we moved to, within the quadrilaterals, we went to the parallelogram. You don't have to write this down. And now where we're going to go from here is into three specific types of parallelograms. They are the rectangle, rhombus, and square. Next page. Okay, so here they are, the rhombus, the rectangle, and the square. And let's go ahead and define each of these, and then I'm going to give you a diagram of what they look like. A rhombus. Have you heard the term rhombus before? What comes to mind when you hear the rhombus? Okay, a rhombus is a parallelogram with four congruent sides. Okay, so the diagram that we typically see for the rhombus, let's see if I've got it over here. Nope. The diagram for the rhombus typically is going to look like this. And it's going to have those four congruent sides. So congruent means what again? Yes, that's right. All of the sides have the same length. Next up is the rectangle. A rectangle is a parallelogram with four right angles. We all know what the rectangle looks like. It's our four-sided polygon. And then we've got our four right angle symbols in all four corners. Next up is the square. A square is also a parallelogram with four congruent sides and four right angles. So the diagram for the square rather looks like this. That's terrible. Sorry. So we've got our four congruent sides and our four right angles. Next page. So, after reviewing our notes from the previous page, is a square a rectangle? Yes or no? What do you think? And go ahead and check your box, yes or no. And then, is a square a rhombus? Yes or no? By technical definition, a square is most definitely a rectangle. And a square is also a rhombus. Next page. So if we were looking at a Venn diagram, which is what this is, of the three different parallelograms, we've got a rectangle, a rhombus, or a square. If we were to put those into a Venn diagram, it would look something like this. On the blue circle, we would have our rectangle. In the circle on the right-hand side, we would have the rhombus. And then in the center, where the two properties combine here, we would have our square. My pen's not wanting to write. So the way I try to explain it is that if a rectangle and a rhombus got married and had a baby, it would be the square. Next page. Okay, so here's our first question. Is parallelogram ABCD a rhombus, a rectangle, or a square? Explain. Well, let's take a look at our definition of all three of our parallelograms and see what we have. So by definition of a rhombus, what makes a parallelogram a rhombus? That's right, we have to have all four sides congruent. Is there anything in this parallelogram that indicates that all four sides are congruent? No, I don't have anything. How about we take a look now at the rectangle? What makes a parallelogram a rectangle? That's right, we have to have 4 right angles. Do we have 4 right angles? We don't with our markings. We've got 1 here in the top right corner, but we don't have all 4. Remember the properties back in our previous lesson, the properties of a parallelogram tell us that the opposite angles are going to be congruent. So if angle C is a right angle, that means angle A is a right angle as well. And then we remember that our consecutive angles are going to be supplementary, so they're going to equal 180. So if angle A and C are both 90 degrees, that means that B and D are also 90 degrees because they are consecutive and they are supplementary. So by definition, we have a rectangle. And remember, the square is going to be a combination of both of them, but this does not fit the mold because it's not a rhombus. And a square is a rhombus just as a square is a rectangle. So by definition, this is a rectangle only. Let's take a look at our first theorem of this lesson. It is theorem 613. It doesn't have a name, oddly enough, but the definition says if a parallelogram is a rhombus, and I'm just going to say if a rhombus, then its diagonals are perpendicular. So let's take a look at that. So if we have a rhombus, and remember our diagram of a rhombus, we have 4 congruent sides. So if it's a rhombus, then the diagonals are perpendicular. What does perpendicular mean? Do you remember? That's right. Perpendicular means they form a right angle. And we're going to have right angles at all 4 intersection points of the diagonal. Our next theorem, 614, again it does not have a name. It still deals with the rhombus. So if a rhombus, then each diagonal bisects the opposite angles. So if we have a rhombus, meaning all four sides are congruent, then the diagonal are going to bisect the opposite angles. Diagonal 1, diagonal 2. And remember that the opposite angles of any parallelogram, they're already going to be congruent. So that if I have, let's say, angle A, B, sorry my pen doesn't want to work on this tablet, C and D, the diagonal is going to cut angle A in half. It's going to cut angle B in half, angle C as well, and then D also. A and C are already congruent, right? Because they are opposite angles. So therefore, all four angles that are bisected are going to be congruent, and the same thing with B and D. So let's see what this looks like. Let's put it into practice. So we're told that we have a rhombus, it's A, B, C, and D, and we're asked to calculate the measures of the numbered angles 1, 2, 3, and 4 within the rhombus. So how do we... Because the rhombus is a parallelogram, the opposite angles are going to be congruent, as within any parallelogram. So B and D are going to be congruent, and A and C are also going to be congruent. Well, we also know that the diagonals in a rhombus bisect the opposite angle. So that if this part of angle B is 58, that means this part has to be as well. So therefore, 2 and 3 are also 58 degrees. Now let's take a look at angle 1. Angle 1 refers to the intersection point of the two diagonals, right here. What do we know about the intersection point of the diagonals of a rhombus? Do you remember from our previous page, if you need to go back and take a look at that? If we will recall, the diagonals bisect each other perpendicular. If that's true, then the measure of angle 1 is 90 degrees. And that just leaves our very last angle of angle 4. Angle 4 is in the bottom left corner. What we also can see from the rhombus is where the diagonals meet and it forms with the side length, we have a triangle right here. And I know the properties of a triangle. All interior angles of a triangle equal what? That's right, 180. So therefore, the measure of angle 4 plus the measure of angle 1 and the measure of angle 3 all equal 180. So let's go ahead and set that up. So I've got the measure of angle 4 plus 90 plus 58 equals 180. And I'm going to combine my like terms. So I've combined my like terms there. Next, I just want to subtract 148 from both sides. Therefore, the measure of angle 4 is 32 degrees. Okay, now it's your turn. Take a minute and tell me what are the measures of the numbered angles. We've got 1, 2, 3, and 4. And I'll give you a hint. Angle Q and P. Remember, those are consecutive angles, and consecutive angles are supplementary. So I'm going to give you a minute to go ahead and solve this one. So remember that Q and P are supplementary, so they're both going to add up together to total 180. So if Q is 104, what is the measure of angle P? That's right, it is 76. So half of 76 is 38. Okay, so that ends our lesson for today. We are not finished with this notes, but we will finish that up next class period. The first two theorems were about rhombuses, and then the last theorem is about a rectangle, and we will get to that next class period. Please go ahead and move on to your assignment, which can be found in Sycamore and under our Snow Day tab. Thank you all so much. Enjoy your snow day, and see you soon. Okay, what'd you get? So if angle Q and P are supplementary, that means that the two angles added together need to equal 180. So if the measure of angle Q is 104, then the measure of angle P is what? The measure of angle P is 76. And we remember that the diagonals bisect the opposite angles, so we're just going to cut 76 in half. So the measure of angle 1 and 2 are, what's half of 76? .38 degrees. And then we remember that the opposite angles are also congruent. So P and R are congruent. Therefore 3 and 4 are also 38 degrees. So we're going to stop right there. If you will, go ahead and proceed to the assignment that is posted in Sycamore and also in OneNote. If you have any questions, I'll be available online. You can send me an email or pass a note. Either way is fine. And have a great snow day. See you next time. Bye-bye.